Today is going to be easy. It's the same exact thing. We're still fundamental theorem of calculus. So fundamental theorem of calculus continued. Don't forget to integrate f of x dx when you have limits of integration, a and b, a being your lower, b being your upper limit of integration. The answer is the integral evaluated at the upper minus the integral evaluated at the lower. And then that gives you a numerical answer, not a function plus c like we were doing in the beginning. All right, so that's that. Now, all of today is, you probably really don't even need this, and I'm going to fly through it pretty quickly, but I'm just going to just show you a couple things just so you remember. So the process, you know absolutely everything. Just if I asked you to do something like find the integral from 0 to 1 of x squared minus 5 cubed dx. Well, the only way you can do that is by expanding it first. There's no chain rule for integration. Okay, there's no chain rule for integration, so you wouldn't be able to take the derivative of the outside, leave the inside alone, multiply by the derivative. You can't do that. All right, that doesn't exist. So we're going to work on some other things though with composites, but that'll come in a section or two. But so you can't do anything other than expand it. And I'm not going to bore you, but what I am going to say is don't forget that to expand anything bigger than, a power 2, you just use Pascal's triangle. So it's going to be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So I'll do a step or two, and then we'll talk about the rest. So using Pascal's triangle, remember these are the coefficients. So let's go ahead and rewrite that from 0 to 1. So my expansion would be my first term. So my first term is x to the power of 2. Obviously, the coefficient of 1's right there, but since 1 times anything, I'm going to ignore it. It's my first term to the power. So x squared cubed is going to end up being x to the 6th. Then we move to the next term. I grab the coefficient there, so it'll become 3 times. Then the first term drops a power, so it's x squared squared. And the other term, negative 5, climbs up a power. They'll always add up to 3, so on and so forth. And then you'll just finish all of that. Then what you have is a very simple add 1 to the power, divide by the new power rule. Then you've got it out of that binomial. So that's that. So really remember Pascal's triangle, get it out to where you can apply a rule that you know. Then we have the type that are written as fractions. So for now, the only type of fraction you can really deal with is something like this. And this is the type where the denominator is a monomial. Why is that important? Because when the denominator is a monomial, you can break it up. Well, technically, you can break it up into that. Right? So you just use your algebra and break it up. Once you've done that, then it's a add 1 to the power, divide by the new power business. And good to go. Just do the f of b minus f of a, and Bob's your uncle, you're home. Okay? Then check the answers on CalcChat or in the back of the book, and then ask me questions. So from here, if I got negative 1 to 1 on square root x minus the cube root of x squared all over 3 squared dx. Now that one's got a lot of things going on. You've got a binomial being squared. Some of you might split it up, some of you might not. Doesn't really matter. Some of you, I would definitely advise you. I would advise you change the radicals to powers. So I would say this is going to be x to the 1/2 power minus x to the 2/3 power all over 3. That's all good, right? And then it's going to be, let's just do it. It's just going to be simple, right? So we're going to have -1 to 1. I'm not going to do the whole thing. I don't want to bore you. So you've got the numerator is going to be the numerator times the numerator. So it's going to be x to the 1/4 power minus 2 times the product, right? So 2 times the product is going to be x to the 1/2 plus 2/3. So we'll do that in a second. Right? And then last term squared. So x to the 2/3 squared. So that would be what, 4/9? All over 9. And then you could split it up from there. You and I remember when we multiply like base, we add their exponents. So this would be 1/2 is really the same thing as 3/6, and 2/3 is the same as 4/6. So that middle term will end up being -2x to the 7/6. Then just break it up like we did before, add one to the exponent, divide by the new exponent, and march on through. All right, and then f of b minus f of a and go. All right, so absolutely nothing new learned. You know that f of b minus f of a, that was yesterday. You've done all of these tricks before. You've done Pascal's triangle, you've dealt with monomial denominators, and you've dealt with radical indices. So just refreshing you to get started. So the homework practice, or the independent practice to generate questions, is on page 291, and that would be 11 to 21 odd, please. If you can get most of that done, you're in a pretty decent place. All right, anything for the good?